Alright, let's program our timers. I already created here an empty project ready to start working, and I'm going to open my libraries. I'm going to source, and we are going to work with the library for the timers, which is this over here, timer.c. So I'm going to open that one, and we have a couple of directions in how to use this driver, but actually what we are interested in, so if you scroll down, is going to be on this one, how to use for timing mode. That's why we want to use our timers. We're going to pretty much follow the directions over here. So before going on our timer, let's just copy some stuff really quick from our previous project. So let's go here. I don't know, let me open GPIO, for example. Open this project, go to main, and I'm going to copy these LEDs and the structure also to initialize the LEDs. So this part over here, go and copy. I'm going to pass this structure inside. I don't need buttons. I have all the orange, green, red and blue LED declared properly, passing, and good to go. All right, let me close project. Here we go. Let me compile, or let me run. Let me toggle one of these really quick here, or turn it on. Let's do a GPIO right bit. Let's do the red LED, and let's do a bit set. Let's turn it on. I'm going to compile, make sure that everything is deployed on the board properly. Press play, and my red LED should be on. It's not. I need to initialize my function and compile. And here you go. Red LED is on. Perfect. And now that I have my LED, let's start defining the timer. So I'm going to create void. I'm going to call init timer. It's called init timer 2. Alright, perfect. And so I don't forget again, I'm just going to call it here, so I know that it's going to initialize that one. I don't need this GPIO for now. And let's go back to our timer.c. See what we need to do. We need to enable the clock of our timers, so the APB. So let's copy this one. Let's go to our main and initialize this one. And now I need to know in which bus is timer number 2. This is going to be timer number 2 is connected to. So let's go over to the rcc.h, and let's go down and find our, here you go. This is for the peripherals, and I want to find for timer 2. Here you go, it's on APB1. So I go back to my main, place it over there, and I know that this is APB1. Perfect. Now let's keep going on our timer C. Now I need to find this init structure with the desired parameters, and then pass on my on my time base init. Alright, cool, let's do that. Let's go here. This is my function. If I want to know a little bit more about this function, again, right click, open declaration, goes inside of these. So the first one is my timer, so I'm using my timer 2, so let's put timer 2. And this is going to be a pointer for that structure, for that init structure. So let's go back here. This is the structure that I am interested in. So I'm going to create that structure. So struct time, I'm going to call timer. And this is what I'm going to pass. And let's see the parameters, what we have inside of this structure. We have a bunch of stuff over here, so we need to parameterize that timer. Clock division, counter mode, period, prescaler, and repetition counter. So again, if we don't know what's going on here, we go back to our time-based, right click, open declaration, and here we have our types. And on this case, we're going to define the prescaler. So let's go back to our slides here really quick. We are defining this prescaler and the counter mode. What type of counter mode do you want? When is it going to overflow? Clock divisions and repetition counters if you want to do more than one time. Generates, counting, restarts. Alright, cool. So let's start with our counter mode, which is probably like the easiest one. Counter mode, and our counter mode is going to be either up, down. We're going to pick up, a counter mode of going up. So where do I find information about my counter mode? So inside of timer, so on the timer.h here, if I want to get a little bit more information, notice that these are no structures anymore, so I cannot do a right click and find what's going on here. But if I kind of try to find information with these names here, so if I keep scrolling down, I'm going to give you some defines here, and here you go. Counter mode, I'm going to use the counter mode up. Going to my main and going to count up. Alright, let's keep going. Clock division. Yeah, instead of like being randomly trying to find that, going back to my declaration here, and we have our clock division. So I'm going to try to find something with these words. So Control F, find these. And now I just, here you go, just press find, and I have different divisions. I'm not going to use any division for that one. Division 1. Let's now define the prescaler. So for the prescaler, we need to know what is, let's go back here to our timers, and in order to define this prescaler, we need to know what speed is kind of entering this prescaler. So what clock are we taking into account before we do the prescaler? So where do we get that information? Where do we get the information about, which is this part over here? So this clock, PSC, this part, this one, this is coming from this clock 3, which it feeds over here. This is what it's feeding that. So we need to understand what's going on until we get over there, so then we can start doing some math. So we know that the board is working at 168 megahertz. Let's see what are these prescalers for the bus, the AHB, APB that are defined on the board. So how do I get that information? If you go back to your system STM, so we're talking about this file over here, and I double click. If you remember, this is where you have a table that defines your system clock, and also how is it configuring the PLL for the rest of the clocks. And if you pay attention here, the AHB prescaler is 1, and then the APB1, which is the bus that we are interested in, the prescaler is 4. So what we're doing is we have 168 megahertz. So let's go back to this one. We have 168 megahertz. The AHB prescaler is 1, divides by 1, so I still get 168. But then I divide by 4 on my APB1. And if I divide by 4, then I get 168. So let's follow that up with calculator here. So you get your 168 megahertz divided by 4. So right now, at this point, you have 42 megahertz. But then there is this thing over here that says that if APB prescaler is equal to 1, then multiplies by 1, else multiplies by 2. So our APB is not 1, is actually 4. So I'm going to multiply now these by 2, which is the same thing as just dividing by 2 initially. So right now, I know that my timers, my APB timer clocks are running at 84 megahertz. So this is what it's going and entering over here. Is going to be 84 megahertz before your prescaler. All right, so let's go back. Let's go back here to my main. I'm going to put just a quick note here that timer clock for now is 84 megahertz. That's just a reference for me. And now the prescaler, we can use that. This is a prescaler that we're going to use on our timer here. So let's see, let's divide by, let's see, we have 84, 1, 2, 3, 1, 2, 3, 84 megs. Let's divide by, I don't know, 4,200, and it's giving me 20k hertz. All right, so let's do 4. And this is giving me 20k hertz. So remember, this is the clock that I'm providing here for the counter. So now each count is going to be done at the inverse of this. So I'm running at 50 microseconds. So I'm going to write here 50 microseconds each bit. Perfect. And now let's keep going. And we have now the period. It's how many times am I going to count these 50 microseconds so the timer expires. And let's count around 10,000 times so we can do 500 milliseconds. So right, so if I go here and then I multiply these by 10, 1, 2, 3, 10,000, I get my 500 milliseconds. All right. This is going to be 500 milliseconds. This is how my timer is going to run. The timer is going to expire every 500 milliseconds. All right, what else am I missing? Something else? Let me see. The repetition counter, we don't have that. We say 0. We don't need any repetition counter. All right. We passed the structure, everything is fine. Let's see what else it's missing. I'm going back to my timer C directions. Let's go up. Here you go. Do all this stuff. We're not going to do the interrupt routines for now. We're going to leave this in a minute, and we just need to enable our timer. The command. Let's see if I can find this command. Open declaration actually receives the timer and the state. All right, timer 2 and then state enable. So I go here, structure. Let's do timer 2 and enable. Perfect. Let's see. Let's compile for now. No problem at all. And now let's see, how am I going to check if this timer is running or not? Because right now I have the timer, I enable the timer, I set it up the timer. to be expiring every 500 milliseconds. Let's do a pooling method here, which is not the efficient way of doing things, but let's just kind of see if it's working by blinking the LED here. So I'm going to use a pooling method. Remember, it's not efficient. We'll fix it in a minute. And inside of our timers.h, if I go down, I have a bunch of functions that I can use. There is a function called getCounter. So if I go here, timer getCounter here, that gets the value of your counter. So let's use this function here, and returns, sorry, didn't pay attention, win32, so 32 bits. Perfect. So let's declare here a variable timer value, and this is coming from my timer 2. Okay, let me declare these up. All right, and if timer value equals to 10,000, which is those 500 milliseconds, I'm going to toggle. Is a function called toggle bits, GPIO and LED. Let's do the green for now and see how it works. All right, let me compile, deploy the code. I have connected to my board an oscilloscope. I know that the green LED is connected to pin 12. So what I'm going to do is I'm going to use an oscilloscope here and turn it on and see if my LED is blinking properly. So you're going to see your LED blinking. In this case, I just have the GPIO toggling, and we have here 510. Let's put 500 milliseconds per division. And here you go. It's kind of going every second. Or I have here also the measurement. And this is the pooling method, which has some disadvantages, because if I go here, I'm just running this on my code, so it works slightly okay. But if I have to, let's say, do a little bit more code, random code over here, just a random value over here. All right, and I run this code now. Let's just wait, compile. So this is my way of showing the LED blinking right now, measuring things a little bit more accurately now. And as you can see, it doesn't behave good at all. Sometimes it does, sometimes it doesn't, because I'm not checking the value at the right time when it expires. It's whenever it's 1000 randomly, just shows up this.